On December 5, 1943, at the Norfolk Naval Shipyard in Portsmouth, Virginia, the third Essex-class fleet carrier left dry dock under gray winter skies. Its hull number, CV-11, identified the USS Intrepid, one of a continuous series of large carriers built under emergency wartime schedules. Observers recorded that the ship's displacement reached 27,100 tons, with a flight deck length of 872 feet and beam of 147 feet at the widest point. American officers described the launch as routine. Japanese naval intelligence later classified the event as evidence of accelerated ship production capacity. At the same time, Imperial Japanese naval attachés in Berlin transmitted intercepted reports from U.S. coastal shipping bulletins. Their summaries confirmed that multiple Essex-class hulls were under simultaneous construction at Newport News, Brooklyn, Philadelphia, and Puget Sound. Analysts in Tokyo concluded that the United States was producing major combatants faster than Japan could complete destroyers. One officer, Commander Hattori Masaru, wrote in a January 1944 dispatch that the number exceeds prior naval ratios by an order of magnitude. Inside the Norfolk yard, documentary footage captured organized activity, cranes, riveters, welding crews, and prefabricated hull sections moving by rail. The Bureau of Ships reported 24-hour continuous shifts, each employing over 20,000 civilian laborers supported by Navy inspection teams. Daily progress logs indicated that prefabricated deck assemblies were aligned and welded within 6 days, compared to pre-war standards of several weeks. Production records reveal the integration of industrial subcontractors across over 150 factories, providing engines, armor plate, and aviation fuel systems. At sea trials in January 1944, the newly launched carrier reached 33 knots during measured mile runs off the Virginia Capes. Observers from the Naval Ordnance Bureau documented aircraft handling efficiency exceeding design expectations. Flight tests with Grumman F-6F Hellcats confirmed deck cycle times of less than 90 seconds per launch under full operational load. These timings were transmitted to the Navy Department in Washington for fleet readiness assessment. Across the Pacific, Japanese naval staff aboard the carrier Zuikaku received reports of the Essex series from reconnaissance summaries compiled at Truk Atoll. Intelligence photos taken by Kawanishi H-8K reconnaissance planes showed new American carriers with uniform silhouettes, straight bows, open decks, island superstructures offset starboard. The Imperial Navy's Construction Bureau compared these with earlier Yorktown-class plans and noted significant scaling increases. Their memorandum of February 1944 calculated that the rate of hull appearance indicates uninterrupted industrial flow. In the background of this assessment lay the changing tempo of American logistics. Between mid-1942 and late 1943, U.S. shipyards delivered 8 Essex-class hulls, with an additional 11 already launched by mid-1944. Total manpower in naval shipbuilding exceeded 1.7 million workers, drawn from converted automobile, rail, and steel industries. Government production reports described the process as a standardized assembly of floating airfields. When USS Intrepid departed Hampton Roads for shakedown in the Caribbean, film reels documented its deck crowded with aircraft, refueling lines, and ordnance lifts. Each system was tested against wartime specifications: fuel transfer 1,000 gallons per minute, ammunition elevators 2.5 tons per cycle, hangar clearance 17 feet. These figures appeared in post-trial engineering bulletins distributed through the Bureau of Ships Technical Library. At that same hour, Japanese naval officers convened in Yokosuka's Combined Fleet headquarters reviewing these intercepted materials. Their records show no emotional commentary, only data tables comparing production cycles and estimated fleet tonnage. Rear Admiral Fukudome Shigeru summarized the conclusion plainly. The American rate of replacement exceeds our capacity for countermeasure. By the end of 1943, 3 facts were verified. The Essex-class represented the largest homogeneous carrier series ever constructed. Its production tempo was unmatched, and its completion signaled an irreversible shift in naval balance. By early 1944, Allied naval planners in Washington assessed the Essex-class as the operational backbone of carrier-based warfare. Reports from the Chief of Naval Operations, dated January 12, 1944, confirmed that 24 hulls were either commissioned, launched, or in advanced assembly. Each ship displaced over 36,000 tons fully loaded, carried up to 100 aircraft, and could steam continuously for 20,000 nautical miles without major overhaul. The data formed part of a comprehensive readiness review by Admiral Ernest J. King's office under the War Production Board's maritime program. Industrial correspondence between Bethlehem Steel, Newport News Shipbuilding, and the Navy Bureau of Ships shows how large-scale prefabrication was introduced. Hull sections were produced inland, transported by rail, and welded into place with standardized templates. Blueprints circulated across multiple yards through photostat duplication, ensuring identical hull geometry and interchangeable parts. This process allowed a carrier's primary structure to be completed in less than 12 months, compared to 36 months for pre-war designs. Japanese intelligence services attempted to trace these manufacturing centers through intercepted cargo manifests and aerial photographs. Reports from the Imperial Japanese Naval General Staff dated February 7, 1944, describe multiple inland factories producing hull fragments untraceable by conventional reconnaissance. Field evaluations concluded that industrial dispersal prevents effective interdiction by long-range bombing. This finding directly influenced Japanese planning for homeland defense industries later that year. Within American production bureaus, standardized documentation replaced experimental shipbuilding. The Essex plans were frozen at Revision 5B, authorizing no design deviations except those dictated by damage control studies. Propulsion systems were based on identical Westinghouse or General Electric turbines delivering 150,000 shaft horsepower across for propeller shafts. Uniformity simplified logistics, enabling repair crews from one carrier to serve another without retraining. Naval historians later referred to this as mass construction logic applied to fleet warfare. By March 1944, 6 Essex-class carriers were completing shakedown cruises while 8 more were fitting out at coastal docks. Photographs from Life magazine's industrial section depict rows of identical island superstructures under cranes, with welders working simultaneously across decks. The images circulated through U.S. information channels and reached European embassies, where Axis observers classified them as indicative of unbounded resource mobilization. For Japan, the disparity in resources was already measured. Archival financial records from the Imperial Navy Ministry show that by fiscal year 1943, Japan could allocate material for only one large carrier per year. Shortages in high-grade armor plate, aviation gasoline storage tanks, and steam turbine components restricted progress. Shipyards at Kure and Yokosuka reported average labor forces of 4,000 to 6,000 workers, compared to over 20,000 at an American facility. Strategic correspondence between Japanese attachés in Berlin and Tokyo documented the visible scale difference. Reports from the German Naval Command at Kiel stated that U.S. carriers arrive in serial groups, not as individual units. One translated German observation noted, "They appear to launch carriers as if merchantmen." Tokyo's Naval General Staff classified this as an industrial warfare in maritime form. Meanwhile, the American Navy's Production Board released quarterly figures under the Victory Ship and Carrier Program. Between 1942 and 1945, a total of 24 Essex-class fleet carriers and 9 short-hull variants were completed. Each ship required over 60,000 tons of steel, 400 miles of wiring, and 1,500,000 man-hours of labor. These statistics were cross-referenced with War Department productivity graphs showing a near-linear growth curve through mid-1944. To Japanese observers, these graphs signified an insurmountable industrial momentum. Lieutenant Commander Nakajima Takao, stationed at Rabaul, wrote in March 1944 that our combined fleet tonnage will soon represent less than one-third of the enemy's mobile air power. He included a table comparing American construction intervals with Imperial Navy averages. The figures read, U.S. carrier every 45 days, Japan carrier every 18 months. This numeric reality framed all subsequent operational planning. By April 1944, Japan's naval command accepted that parity could no longer be achieved through replacement tonnage. Instead, emphasis shifted toward asymmetric tactics, kamikaze operations, night attacks, and the defense of island bases. These adjustments were formalized under Combined Fleet Directive No. 373, recognizing that industrial limitations, not tactical errors, defined the coming phase of war. By May 1944, Imperial Japanese Naval Intelligence began a structured analysis of American carrier construction patterns. Reports obtained from the Naval Technical Research Institute, NTRI, in Tokyo examined intercepted radio traffic from San Francisco, Norfolk, and Puget Sound. Decrypted communications confirmed near-continuous shipyard operations organized under a precise rotational schedule. Each Essex-class hull advanced through 11 defined construction stages, from keel laying to final armament installation. A declassified Japanese memorandum dated May 19, 1944, titled Assessment of U.S. Carrier Assembly Systems, described the process as modular integration of standardized naval structures. It identified four principal production zones: Atlantic, Gulf, Great Lakes, and Pacific. Each zone operated semi-independently but adhered to identical specifications issued by the Bureau of Ships in Washington. This decentralized coordination ensured that a material shortage or localized attack could not delay the national schedule. The same report noted that U.S. naval yards employed a rolling assembly system, allowing multiple hulls to advance simultaneously. Shipyard managers implemented time motion studies derived from automotive assembly research conducted at the Ford River Rouge plant. Riveting teams, welding crews, and crane operators followed synchronized schedules logged hourly by Navy production clerks. When the keel of USS Hancock, CVO-19, was laid in January 1943, prefabricated components for the next two carriers were already complete and awaiting transport. Captured American engineering manuals after the war confirmed this efficiency. Each carrier blueprint carried detailed time codes for every sub-assembly, boiler section, flight elevator, arresting gear, and radar mast. Standardization reduced errors, shortened inspection time, and allowed rapid workforce training. American records show that by mid-1944, new recruits could be trained as certified welders in less than 8 weeks. In contrast, Japanese shipbuilding remained craft-based. At Kure Naval Arsenal, hull fabrication relied on sequential manual assembly and individual rivet fitting. A technical report issued by the 4th Naval Technical Department admitted that limited mechanization constrains acceleration beyond pre-war norms. Workshops lacked the heavy lifting cranes capable of moving 100-ton deck sections used routinely in American yards. The Essex-class design itself also contributed to manufacturing simplicity. Its structure featured a straight flight deck, standard elevator configuration, and homogeneous armor layout across all hulls. This allowed interchangeable parts, simplified logistics, and predictable stability under full load conditions. Shipbuilders used 7/8-inch steel plating for hangar decks and 3-inch belt armor on machinery spaces, all produced under unified Navy contracts with Bethlehem and Carnegie Steel. During reconnaissance operations over Pearl Harbor and the U.S. West Coast, Japanese long-range flying boats attempted to photograph these carriers at berth. Few missions succeeded due to extended range limitations and American radar coverage. However, diplomatic sources in Lisbon and Stockholm provided consistent intelligence. New carriers appear monthly, none idle at dock for long. This assessment reached Admiral Toyoda Soimu, who concluded that American naval expansion has entered a self-sustaining stage. Field agents monitoring Pacific operations gathered further proof. After the Battle of the Philippine Sea in June 1944, Japanese survivors reported encountering multiple Essex-class carriers previously unknown to them. Operational logs recorded the USS Lexington, CVE-16, USS Bunker Hill, CVE-17, USS Wasp, CV-18, and USS Hornet, CV-12, all launched within a single 12-month span. The realization spread through surviving air groups that the enemy possessed near-limitless replacements. Technical comparisons followed. American carriers carried 3,400 tons of aviation fuel, stored in protected double-bottom tanks with nitrogen blanketing. Japanese fleet carriers, such as Shokaku, carried less than half that volume and lacked such fire suppression systems. Furthermore, Essex-class ships integrated dual hydraulic catapults capable of launching 14-ton aircraft, expanding operational range and sortie rates. Data recovered from American engineering manuals post-war confirmed these details as accurate. At the strategic level, analysts within the Imperial Navy began calculating cumulative fleet tonnage versus loss rates. By July 1944, the United States had replaced all carriers lost at Coral Sea, Midway, and Santa Cruz, and doubled the pre-war total. Internal memoranda circulated at the Naval Technical Bureau stating, the U.S. fleet regeneration rate exceeds combat attrition by a factor of 4. Rear Admiral Sakamaki, reviewing the findings, summarized, at this pace, destruction of hulls yields no strategic effect. By the end of this phase, the discovery was complete. Japan now possessed empirical confirmation that American naval industry operated beyond the reach of attrition warfare. Material superiority was not theoretical, it was quantified, documented, and verified through intelligence, observation, and direct combat encounter. By August 1944, the Imperial Japanese Navy's Operations Division concluded a classified evaluation titled Report No. 174 of American Carrier Output and Strategic Implications. The findings were circulated among senior flag officers at the Naval Staff College in Tokyo. The document's language was restrained but definitive. The United States Navy has achieved industrial self-replication of fleet strength. Copies were marked secret, destroy after reading. The analysis began with verified statistics. Between 1942 and 1944, the United States launched over 20 Essex-class fleet carriers, averaging one every 58 days. By comparison, Japan had completed 4 major carriers in the same period, including Taiho and Unryu. The difference was not attributed to technical skill but to resource integration and machine-based construction efficiency. Charts within the report showed steel allocation, labor mobilization, and energy consumption per ton of ship output. American shipyards consumed 10 times more raw material than Japan could mine or import under blockade conditions. The authors concluded that Japan could not sustain a counterbuilding effort even with maximum rationing. Instead, they recommended prioritizing defensive positions, fuel conservation, and special attack tactics. At Yokosuka, naval engineers reviewed intercepted U.S. Navy Yard bulletins detailing the assembly of USS Bennington, CV-20, and USS Boxer, CV-21. Each document demonstrated consistent milestone achievement, keel laying to commissioning in less than 1 calendar year. Japanese technical officers compared these results with their own delays at Kure, where turbine fabrication alone required 11 months. The contrast was entered into the combined fleet's operational study as proof that the industrial contest was mathematically unwinnable. Admiral Ozawa Jizubo's staff at 1st Mobile Fleet Headquarters received these data prior to the Philippine Sea engagement. His intelligence summary, dated June 10, 1944, included the statement, "Enemy carriers are now products of industry, not craftsmanship." The phrase circulated quietly through the senior ranks. It described not only material reality but a transformation in naval doctrine, the replacement of artistry with industrial repetition. Operational evidence soon confirmed the assessment. During the Battle of Leyte Gulf in October 1944, Japanese pilots identified at least 10 different Essex-class carriers operating simultaneously. Their deck markings, radar masts, and hull forms appeared identical, creating confusion in combat identification. Post-action debriefings recorded comments from Japanese aircrew noting, "Each ship destroyed is replaced by another with the same outline." That observation matched precisely the conclusions of the earlier intelligence analysis. Strategic Command minutes from the Imperial Navy's Combined Fleet Conference on November 3, 1944, record Admiral Toyoda Soemu's remarks. "The opponent now fights a war of replacement, we fight a war of exhaustion." His statement was transcribed by Lieutenant Commander Nishida Masashi and archived in the War History Office. Following the conference, the Naval Technical Department ceased proposing large carrier designs. Resources were redirected towards suicide aircraft projects and small ship construction for homeland defense. Meanwhile, Allied intelligence units monitored Japan's growing awareness of American productivity. Interrogations of captured Japanese officers in 1945 revealed near-universal reference to the Essex series as the Infinite Fleet. One interrogated engineer from the Cure Yard admitted, "We realized we could no longer measure time in ships, only in losses." These testimonies were later compiled in U.S. Naval Intelligence Summary No. 121, issued in July 1945. On the American side, the Navy Department acknowledged Japan's recognition. A memorandum from the Bureau of Ships to the Chief of Naval Operations dated January 1945 stated, "Enemy assessments confirm that production tempo alone has become a weapon." This concept, industrial tempo as strategic force, became a recurring post-war theme in naval study circles. By the end of 1944, the realization within the Imperial Navy was complete and irreversible. Its officers understood that every sunk American carrier represented not victory but delay. The war had entered an economic dimension governed by output, manpower, and standardized machinery. Japan's leadership, constrained by geography and limited resources, could not match the arithmetic of American manufacturing. Thus, the Essex-class carriers ceased to be viewed merely as warships. They became symbols of an industrial system functioning at full wartime efficiency, immune to conventional attrition. In strategic terms, the Japanese Navy's realization was not emotional, it was quantitative, measured, and final. By early 1945, the statistical scale of American naval shipbuilding reached levels unseen in maritime history. U.S. Navy production tables for the Essex-class series showed that by March 1, 1945, 24 fleet carriers were fully commissioned, 5 more launched, and 4 under fitting out. Together with Independence-class light carriers and escort carriers, the United States controlled over 1.2 million tons of operational carrier displacement. The figures were verified through the Joint Army-Navy Production Board's Quarterly Report No. 10, archived in Washington. War Department memoranda confirmed that the industrial base supporting these carriers extended across 42 states. Machine shops in Detroit, Pittsburgh, and Chicago fabricated turbines, boilers, and hydraulic systems previously produced only on coasts. The distribution of subassemblies by rail networks allowed inland factories to function as extensions of coastal shipyards. This decentralized framework ensured uninterrupted production even when specific yards reached maximum capacity. In Tokyo, naval intelligence analysts attempted to graph the cumulative American shipbuilding rate against Japan's industrial output. The resulting curve, rising steeply from 1942 to 1945, formed a visual representation of strategic imbalance. An internal summary titled Relative Maritime Construction Capacity concluded, by 1945, the enemy constructs the tonnage of the Imperial fleet every 100 days. The document was retained in the post-war U.S. occupation archives as evidence of Japan's late-stage economic awareness. Meanwhile, at American shipyards, production became nearly automatic. Welding techniques were standardized, documentation reduced to checklists. Each Essex-class carrier required approximately 1,000 subcontractors, from turbine manufacturers to optical rangefinder specialists. Automation in plate rolling and pre-stressed riveting reduced construction time by nearly 40% compared to 1943 averages. Government observers described it as mechanical rhythm, a phrase later adopted in post-war industrial management studies. Strategically, the United States began to treat carriers as modular fleet units rather than singular assets. Pacific Fleet records show that damaged Essex-class ships returned to service within 6 weeks on average. Floating dry docks at Ulithi, Manus, and Pearl Harbor handled continuous repairs, maintaining operational strength across multiple task groups. Rear Admiral Forrest Sherman's report to Admiral Nimitz in May 1945 stated, "Fleet rotation no longer constrained by shipyard space." For Japan, these observations forced a redefinition of strategic goals. Fleet reconstruction was abandoned, resources shifted to air and coastal defense. At the same time, fuel shortages paralyzed operational readiness. Japanese shipyards, lacking steel and electrical capacity, suspended all new carrier work by February 1945. The Unrai class remained incomplete, its sections left rusting in dry dock as Allied bombing raids intensified. Intelligence intercepts by the U.S. Office of Naval Intelligence, ONI, recorded references to Japan's internal despair. A decrypted message from Kure Naval Arsenal, dated March 27, 1945, stated plainly, shipbuilding schedule impossible to resume, facilities 70% damaged. Photographic reconnaissance over Yokosuka confirmed destroyed cranes, submerged hulls, and twisted girders among debris. The once ambitious imperial shipbuilding network was now functionally extinct. In contrast, American shipyards increased efficiency despite labor transfers to the European theater. Civilian reports from Newport News Shipbuilding noted that USS Philippine Sea, CV-47, was completed ahead of schedule despite reduced manpower. Industrial synergy between private companies and the Navy remained uninterrupted due to rigid scheduling, standardized documentation, and continuous funding. Each yard operated under government-mandated production quotas verified monthly by the Maritime Commission. Economists attached to the U.S. War Production Board later evaluated this achievement as the practical application of total war industry. Their post-war study industrial mobilization in naval construction defined the Essex program as proof that assembly line methodology can govern complex capital ships. They cited production ratios: Japan, 2 large carriers in 1944, U.S., 12 large carriers in the same period. No tactical decision, they wrote, could offset that industrial arithmetic. As the Pacific War neared its end, surviving Japanese officers observed the relentless emergence of new American hulls. Each represented not an individual ship but an index of national output. Imperial memoranda described the situation as a stream without end. That description, though simple, encapsulated Japan's final comprehension: industrial capacity had become the decisive weapon of the war. By the time Japan's remaining fleets withdrew toward home waters, the Essex-class carriers had transformed from strategic assets into instruments of inevitability. Their uniform silhouettes and endless sequence symbolized the logistical dominance of the United States. In global terms, The context expanded beyond shipyards. It illustrated the era's defining reality, the mechanization of warfare through industrial scale. By September 1945, the war in the Pacific had ended. Japan's remaining naval officers, detained and interrogated by Allied authorities, reflected not on tactics, but on production. Their testimonies formed the foundation of postwar analyses compiled by the U.S. Strategic Bombing Survey Naval Analysis Division. The documents revealed a collective acknowledgement that industrial scale, not naval skill, determined the outcome. Vice Admiral Kozaka Rinosuke, former Chief of Staff of the Combined Fleet, stated during interrogation, "We understood by 1944 that America was constructing carriers faster than we could destroy them." His assessment appeared in Interrogation Report Number 42, filed on October 3, 1945. The tone was factual, without bitterness, an engineer's recognition of a system beyond replication. Post-war Allied evaluators catalogued the Essex-class program as the decisive logistical achievement of the U.S. Navy. The series represented not individual victories, but sustained capacity. Of the 32 hulls authorized, 26 were launched before the Japanese surrender. Each shared standardized propulsion, layout, and aviation facilities, forming what internal Navy memoranda called a reproducible fleet. American reports emphasized the institutional mechanisms behind that reproducibility. Continuous funding through the Two-Ocean Navy Act of 1940 guaranteed material and labor flows across the entire war period. Naval shipyards operated without pause for 4 consecutive years, supported by industrial centers producing machinery, armor, and aviation fuel. The process, once begun, could not easily stop. It had become self-sustaining. In contrast, Japanese shipbuilding never recovered from cumulative losses. Kure, Yokosuka, and Sasebo yards suffered destruction rates exceeding 70% by mid-1945. Archival photographs show half-assembled hulls covered with rust, flooded dry docks, and silent cranes. Workshops lacked electricity, fuel, and raw steel. Laborers were reassigned to civil defense duties. Even if the war had continued, resuming ship construction would have required years, not months. American technical missions visiting Japan after surrender documented these contrasts with precision. Reports by the Joint Army-Navy Technical Evaluation Team, JANET, in November 1945 noted, Japanese naval construction practices remain pre-industrial in tempo and scope. No evidence of large-scale modular integration was found. Their summary recommended studying U.S. shipyard methods as the definitive model for modern naval industry. Former Imperial engineers, when interviewed by occupation authorities, described a quiet realization that predated defeat. Commander Kobayashi Keiji of the Naval Technical Department remarked, "We measured progress by completion. They measured progress by repetition." His statement summarized the conceptual divide between craftsmanship and mass production that defined 20th century warfare. It was included verbatim in Occupation Report Number 128, Japanese Industrial Lessons, Shipbuilding. By 1946, the Essex-class carriers began transitioning into peacetime service. Several, including USS Hancock and USS Ticonderoga, entered post-war modernization programs under the new angled deck and jet compatibility conversions. Their continued use into the 1960s and 1970s demonstrated the durability of their original design and the foresight of wartime standardization. Naval historians later classified the Essex lineage as the most successful capital ship series in modern history. In strategic retrospectives, Japanese naval officers often cited the Essex-class program as the practical manifestation of America's industrial power. Rear Admiral Fukudome Shigeru's post-war memorandum concluded, "Our error was believing that victory rested in combat performance, not construction capacity." The U.S. Naval War College incorporated similar conclusions into its 1947 lectures on industrial mobilization and sea power. The Essex-class became both case study and symbol, a lesson in how material production could exceed tactical brilliance. The reflection extended beyond technical evaluation. Post-war economists, studying wartime mobilization, defined the Essex program as a model of logistical synchronization. Their analysis described how a democratic industrial system, once organized, could sustain global war through distributed efficiency. The data validated a new doctrine that control of production determined control of strategy. By the late 1940s, many Essex carriers remained active, their hulls unchanged except for new radar and flight systems. They represented not relics of war, but durable monuments to an industrial transformation. In that sense, the ships outlived the conflict that created them. For Japan's surviving naval officers, the conclusion required no further debate. When they had first observed the carriers rolling off American assembly lines, they had recognized a truth that the war would soon confirm. That speed of production, measured in steel and labor, had replaced the art of battle as the measure of power.